All right. So today, we're going to draw some more structures and learn a different way to look at them. Okay? And we're going to focus on not on the atoms, but on the bonds. Okay? So what we're trying to do is figure out before we draw anything if you need multiple bonds. So before you do anything, can we check and see if you're going to need multiple bonds? Okay, it's going to involve some simple integer math. Step number one, add up all the valence electrons you have available to work with. The total number of dots you're going to draw when you're done. We're going to call this, creatively enough, the have number, because that's how many electrons you have. When you're done, you have to have those many dots. Okay, that? That's what we're getting, is the number of dots you need when you're done. Okay. Then, count out the total number of electrons you would draw if every atom was noble gas by itself. How many total electrons you would have if everything was happy, unattached, just by itself sitting there, the total number of electrons. So this is either going to be 8 or 2. Those are the only two options for each atom, right? 8 if it's anything other than hydrogen. If it's hydrogen, it's 2. So if I had 4 atoms and none of them were hydrogen, my happy number would be 40. So I have 5 atoms. Each one wants to be happy with 8, so my happy number would be 40. Okay, that? Then subtract. Happy minus have. Because the happy number is going to be bigger than the have number. And then divide by 2. You divide by 2 because you're going to count the same electrons twice. So the top number tells you how short of electrons you are. You divide by 2 because you're going to make up that shortage with bonds and you're going to count the same electron twice. This will tell you how many bonds there are. Happy minus have divided by 2 tells you how many bonds there are. Now, to figure out if you need multiple bonds, well, it's a simple demonstration. What this sentence says, all single bonds is one less than atoms. This is what it's talking about. If I want to hook up 2 things, how many bonds would it take? 1. So to hook up 2 things takes 1 bond. What's the minimum number of bonds I can get away with to hook up 3 things? 2. What's the minimum number of bonds I can use to hook up 4 things? 3, right? So have you noticed a pattern to this? If you have, you'll be able to answer this question. What's the minimum number of bonds to hold together 25 atoms? 24. Right? So if they're all single bonds, you will have, your math will say 1 less bond than there are atoms. If it's bigger than that, you have an extra bond. Okay? Okay? And then once you've drawn in the bonds, then fill up the atoms. So a couple of examples. So just fill them up. Everybody's going to look like a noble gas. And to count, when you're done, check to make sure you have the right number of dots. Because when you started this, you said, hey, this is how many dots I should have when I'm done. Right? That's where you start. So that should be the last thing you check. Did I draw that many dots? Or lines the equivalent thereof? So, NH3. Do I need to do the math to show how NH3 is going to fit together? Can you see how NH3 would fit together without that? Okay, I do not do the math every time. My first step is, can I see how they fit together? If I can, I do that. But if I can't see it right away, then I look at the math. Does that make sense? I'm not going to do the math unless I need to, but I want to show you the math works on something pretty simple. Okay, so n. N's half number is 5, and its happy number is 8. Everybody okay with that? It has 5 valence electrons. It'd be happy if it had 8 electrons around it. The hydrogen has 1, and it would be happy with 2. But there are 3 hydrogens. So my half number is 5 for the nitrogen plus 3 times 1 for the hydrogen. Means my half number is 8. When I'm done, there should be 8 dots drawn, because that's all I got to work with. My happy number is 8 for the nitrogen, 2 for each hydrogen times 3, because there's 3 of them. My happy number is 14. Okay. Happy minus half, 14 minus 8, divided by 2 is 3. My math says this is supposed to have 3 bonds. What does that tell me? Okay, well, I got NH3, that's 4 atoms. What's the fewest bonds I could get away with? 3. And I have to put in 3. So I don't have any extras. These are all going to be single bonds. 4 atoms with 3 bonds is all single bonds. And I know that before I draw anything. I said it was pretty simple math, right? No, I mean 4 atoms, NH3, 1 N and 3 H's. To hook those 4 atoms together, the minimum I can get away with is 3 bonds. All right? And now that I know that, I don't care where the electrons come from. Okay? I just put them in. There's my 3 bonds. Okay? And then the rest of the fill in everything to make everything happy. The hydrogens are happy. The nitrogen needs another pair in order for it to be happy. And now I can check. How many dots have I drawn there? 8. What was my half number when I started? 8. I have the right number of dots, and everybody looks like a noble gas. This is probably the right one. Make sense? Okay. So, a different way. Notice we didn't follow dots moving around or anything. Once you've decided to do the math, you don't care where the electrons came from. If you want to know where the electrons came from, you can't get away with. You can do the math, but you actually have to build it to follow those rules. Okay. So, HCN. And I'm going to tell you the carbon is central. It's the lowest electronegativity. Okay. HCN. Oh, this is a hydrogen cyanide. It smells like almonds. Then you die. Carbon, nitrogen together, cyanide. Okay. Okay, so N. We did this one last time. It was 5 valence electrons it has. Its happy number would be 8. Carbon has 4. Its happy number is going to be 8. Hydrogens has 1. It's going to be happy with 2. So HCN has 5 plus 4 plus 1. That's 10, because there was 1 of each. Its happy number, 8 plus 8 plus 2. 8 for carbon, 8 for nitrogen, 2 for hydrogen. That's 18. Happy minus half, 18 minus 10 is 8, divided by 2 is 4. Okay. Now this is going to help us build our structure. How many atoms do I have? 3. So what's the fewest bonds I could get away with? 2. And I've got to draw in 4. I've got 2 extras. I'm going to have some multiple bonds here. Okay? And I know the multiple bonds can't go on hydrogen. Are we okay with how I can make that decision so fast? Hydrogen can only make 1 bond at a time. So I know I have to put in extra bonds and they can't go on hydrogen. Okay, so that's what we said we're going to do. I draw in my bonds. There's the 2 bond minimum. Hydrogen hooked to carbon, hooked to nitrogen. So first you put in the single bonds. I still need 2 more bonds because we said we were going to put in 4. That's only 2. And they're not going to go on the hydrogen, so where must they go? Between the nitrogen and carbon, right? Single bond must be a triple bond. Okay, now I need to fill everything up. The hydrogen is filled. The carbon is filled. The nitrogen only has 6. So I have got to fill up nitrogen's octet. And now if you check, I've got 2, 4, 6, 8, 10 electrons. My half number was 10. Now, here we didn't have a real choice about where the multiple bonds went. They had to go between the carbon and the nitrogen. But if you got a choice, how do you pick where your extra bonds are going to make? Where do the extra bonds go? And this is where you want to think of holes they need to fill. Because the way they're going to fill that hole is by sharing with somebody. So instead of thinking about how many valence electrons it has, think about how short it is from being full. That will tell you how many bonds should be the default choice for this atom. Now this isn't a guarantee, but it should be our default choice. Well, actually one of them is a guarantee. H will always make 1 bond. Okay? Because once it gets to 2 valence electrons, it looks like helium, it's done. Hey, oxygen. 6 dots. How many bonds should it form? It's got those 2 holes need to be filled, so oxygen should form 2 bonds. If there's a way to make oxygen make 2 bonds, you should try to do that. May not be possible, but when you can't, that atom tends to be that molecule tends to be really unstable. N, 5 dots, should form 3 bonds. Carbon should form 4 bonds. Actually, it's the ability of carbon to bond with 4 things that makes all sorts of chemicals possible, because you can have chains and branches then. And you can build complicated molecules. You can hook them together 4 different things on. I left off the halogens. How many bonds should the halogens form? 1, because I got 7 dots, right? Halogens, 1 bond. If possible. May not always be possible. But that should be your first try. So just make sure we're all in the same category on this, same place. How many bonds should sulfur form? Okay. Everybody see that sulfur should form 2, okay. Okay, now let's turn it the other way. Which of the following shouldn't make a double bond? Should not make a double bond. Oh, carbon makes 4 bonds. Oh, okay, so which one shouldn't make a double bond? We just said the halogen should make 1 bond, right? All right, it's got 1 hole to fill. Okay, so that's why I want to do this a separate way. You may not even have to do any of the math to do that. I wanted to introduce it because that's the way we're going to need to do the next few things we do. Because the book tells you to try to figure it out where there's an extra electron someplace, and they don't tell you where the extra electron is. I don't know how they expect you to do it. I need to do the math here some more. Okay. So the front half of this page is about the ionic compounds. The back half is about covalent compounds. Make sense? Do you have to do the math every time? No. If you can see how they fit together, I'd do that first.